this video, we are going to make a AI patrolling system. So we got these 4 waypoints. You can add more waypoints and you can use that as well. So you can make a different kind of pattern. And it's just a simple, easy patrolling system for like a guard, or you maybe have an NPC or something. So let's just jump into it. So start out by adding a terrain to our project. So inside 3D object terrain, we just gonna make it a tad smaller. So you click on the terrain, click on this icon, and you can see there is the terrain width and length, and I put it to 100 times 100. So now it's a bit smaller. Then we're going to add a script, call it patrol pattern. And we're going to open up the script. And just remove the start and update. We're going to write const float. And this is for determining the size of the small balls on the platform. So we're going to call it waypoint or radius and set it to 0.5. Then we're going to make a private void on draw gizmos. And here we're going to write all we need to draw our gizmos. And it will look kind of weird because I kind of do it the wrong way around, but I will start to write for int. Just take what I suggest here and I++, and then you can take this part and change it to transform.children. So transform.child count, and then you can say I is less than child count. So we make an int j, which we're going to be using for making the lines between the circles. So we will get the next index, which is going to be I, but we haven't made the next index yet. So you're going to have these red lines under. Then we're going to say gizmos dot draw, and then we're going to choose what type, and this is for the circles. And we're going to take get pos or get waypoint maybe, and we haven't made that either yet, so it will not like that as well. And then we're gonna use the waypoint radius, close it. Then we're gonna say guess mouse and draw line, and we're gonna see that is for the waypoint I. So you can just click on this and put in waypoint and then write I. And where are we gonna draw the line from? Well, from I to J. So we're gonna say get waypoint and again you can click on it and copy paste it in, and from I to J. So let's actually get working on these get point and get index. So we say public int get next index and call it int I, then brackets, and then we're gonna write return, and then we're gonna say I plus 1, and if I plus 1 is equal to transform.child, then we're gonna return 0, like that. So that was the get next index. Then we are going to add the get waypoint. So public vector tree get waypoint and call it int I. And then we're gonna say turn transform get child I dot position, and then we have some few mistakes we need to fix. So here I'm testing out why I keep having the lines. It is because I forgot a semicolon, um, and then I need to add a semicolon after this. So when we got the code, we can close it down, add an empty game object, call it waypoints, and under that we're gonna add a child, call it waypoint, gonna duplicate it, and now when you put out the, or you put on the script here, and then you can set the waypoints out, and it will draw out a line between them. The reason why you can't see it right now is because my uh, y-axis is very low, so you need to like reset the transform. But yeah, of course I forgot to do that, so I'm just gonna do it after I set all of these four out. So as you can see, you have the lines, so we need to bring them up to the surface. So just gonna adjust these so they are actually within the terrain. It is important that it is possible for the character to reach the point, so you cannot make it like far up top in the air or underground. So you need to set the positions so it's possible to touch it. So now when we draw the lines, we can make the next script, which is the AI control script that's gonna make our character walk around. So just open up this new script and delete the start and the update. We're gonna start with a private void patrolling function, and we're gonna add in all the other function that we're gonna need as well. So we're gonna need a private bool, say add waypoint, and we're just gonna write return. So the red line at waypoint will get removed, and then we're gonna make a private void circle waypoint and some brackets, and then we're gonna make a private vector tree get current waypoint and the bracket and write return. So these four functions we are going to make where that we're gonna need. So in the patrol, we actually need some variables first. So vector tree that call it next position, which is going to be stored. So we're gonna store our next position and public float distance to waypoint, which is how close do we need to get to the waypoint before we can say, oh, we are at the waypoint. Uh, Later I will change this name because it's gonna mess up with the other type of code and it kind of get misunderstanding. So, but for now we can write that. So next position is equal to, and then we're gonna store uh, my position. They're gonna say if we have a patrol script attached, but we need to first be able to attach the patrol script. So we're gonna up here make a public patrol pattern, call it patrol pattern with a small p. I'm gonna take the name and put in here instead and say if we, we do have a patrol pattern, then we are going to do some awesome stuff. So what are we gonna do? We're gonna say make this at waypoint to an if we add waypoint. So if waypoint, if what's gonna happen if we are at the waypoint, well then we're gonna cycle waypoints. So we're gonna go to the next waypoint. And next position should be equal to get current waypoint. So now the next position will be the next waypoint. Then we can add the function so we can reach the nav mesh agent, and then we're gonna say get component nav mesh agent dot destination. Where should it go? It should go to the next position. So this is the one that will move our AI. Then we're gonna make a float distance to waypoint, and this is where I realized that we have a name issue. So I'm gonna remove it again and just put it inside here because we don't actually gonna reach it. So float distance to waypoint gonna be equal to vector 3 distance, and then we're gonna measure the distance between the transform position of the character and the current waypoint we are at, and then we're gonna return that information that this waypoint if we are close enough, if we are at it. And again we have a little bit of name issue here, so I'm gonna rename. Let's call it at point, and then we're gonna say distance to waypoint if that is less than at point, well then at waypoint will be true. So that is why we made a bool. So we in the cycle void points we are going to say add a new int and call it current waypoint index and set it equal to 0. So we start at index 0, and then we're gonna say use this current waypoint index to cycle through. As the current waypoint is equal to patrol pattern dot get next index. So the next index, get next index, is a function we had in the other script. So down here in get current waypoint, we will say return patrol pattern get next index. Oh, sorry, we will use get waypoint. Which is also from the other script. And set it to current waypoint index. Then we are going to find a character that we can show this AI controls and see if it works. So we kind of use the asset store, and you can use your own, but I will just show it with this RPG hero. So I will download it, put it into my game. I will open the prefabs, take the little man, put him into the scene, make him a little bit taller. There we go. It looks beautiful. Uh, I will make sure that he's an anime controller. I go into the controller. I can see that they have made like a controller, so you're gonna cycle through all the animations. So I'm gonna create a new blend tree, and I'm gonna call it locomotion. Like this. I'm gonna set it to the default. and then I'm gonna set a new float and call it forward speed. And then I'm gonna open the blend tree, and I'm gonna say the parameter is forward speed, and I'm gonna add 3 motions fields. 2 can be enough. Unfortunately, I didn't use a clean project, so this have a lot of animations. So instead, I just gonna delete it, and I will go lock this one, and I will go into my project, go into assets, go into animations. This is there, and then I will find the idle. I will take the idle and put in. So this is the get hit animation I wrongly took in, but it looks cool. So I put in the idle instead. And because I locked it, I cannot get it back now, but I know this is idle, so I'm just gonna take the next one in, which is gonna be walk and then run. So you can always add to the code that he will be walking instead of running. You can see the threshold, which shall match the speed uh, inside. You can change the speed. Currently in the um, nav mesh agent that we will add is the max speed is 3.5, and you can just set the threshold for running is 3.5 and then write a bit of code that you will be walking at half of it. But let's just adjust the camera so we can see. I click on the camera and I will click align to view. So when I hit play now, I can see that he's idling. Great. So in the script, we are going to make a private void update and put in our function patrolling. So he will actually start to patrol. So when we added the AI control and the nav mesh to our little man, we can see him running around. I might forgot to tell you that you have to bake the scene. So you go to window and you click AI and then you can bake it. But yeah, as you can see, he's going to the far left, which is a bug. And the reason for that is that I forgot to put in the patrol pattern, which is needed for him to actually cycle. So when you have that, he will go to the first marker. When he hits the marker, he will then turn and go to the next. And now it's working. So if you want your character to also to be able to run, you can stick along for a little further, but else this is actually the patrol system, and you can add in new waypoints that will also work with this. So for be able to see the run animation, we will make a private void update animator, and then we're gonna write 4 lines of code, and then he will actually run around. So we say vector c velocity is equal to get component, and we're gonna take the nav mesh agent's velocity, and then we're gonna make another vector tree and call it local velocity is equal to transform dot inverse transformation direction velocity. And I'm gonna make a float speed and say that is equal to the local velocity dot set. And then we're gonna take the animator and say, okay, the nav mesh agent, oh sorry, get a component animator, and then we're gonna set float. So the float we created before the forward speed, we're gonna type in here, and then we're gonna make comma speed. And just to be sure, I'm gonna copy paste this forward speed because it needs to be spelled 1-to-1. So I go into the forward speed and paste it in, and now these two works together. The only problem is that I have not put the animate updater inside the update method, so nothing is happening here. So let's put the update animator into the update method, and then we can try again. Now we have the running soldier. He's running to the first point and then the next point. So thank you for watching. Remember to subscribe, like, comment if you use it. It will help my channel so much. So thank you guys for the time.